Thank you so much. It's a great pleasure to be here. Let us be honest. There are objects in the sky that we don't understand. That's not the first time that we don't understand something. You know, our knowledge, scientific knowledge, is an island in an ocean of ignorance. We don't know what 85% of matter in the universe is. We call it dark matter, but we invest billions of dollars figuring it out over the past half century. We haven't yet figured it out. My point is simple. We should invest $1 billion in figuring out what is in our sky. And that means developing artificial intelligence algorithms, software, that would help us analyze data from state-of-the-art sensors. And in one case, if all of these objects are produced by humans, the Defense Department will have a new tool to monitor what's out there in the sky. It's important for national security. However, if 1 out of 1 million objects came from outside the solar system, the person who finds that object will get a Nobel Prize. It's a win-win situation. We need to invest $1 billion in this task. And I will mention a few details of what we can do with it. This is a subject that the public cares a lot about. And so it's one of the unusual opportunities to invest $1 billion in science and technology that will make all taxpayers happy. If you were to ask them, do they care more about what dark matter is, or whether we have a neighbor that is intelligent from which we can learn, they will tell you it's the second question that they want the $1 billion to be spent on. So to make taxpayers happy, let's invest the money. And if we don't find any technological relics from other civilizations, this would be a very precious defense system for our country. So I will show a few slides describing what we have been doing over the past few years in the project that I'm leading at Harvard University, the Galileo Project. What you see in the first slide is a title of an article that appeared in New York Times Magazine. And I was not happy with the content. I contacted the editor and said, if this is the way you describe science, how can I believe anything you say about politics?
That's a good take.
We can leave now. You've already come out.
Now, Enrico Fermi, in 1950, had lunch at Los Alamos, and in his Italian accent, he asked, where is everybody? And that's a question that every lonely person asks. And what you tell a lonely person is, don't be presumptuous. Your partner will not come to you. You're not that attractive. You had to go to daily sites. And Enrico Fermi didn't even build a telescope to look out, didn't have cameras to check. And so saying, where is everybody, is arrogant. And many of my colleagues in academia argue, extraordinary claims require extraordinary evidence. If you read the news, you would conclude that we are not extraordinary. There is room for improvement. And imagining something like us on a planet that has similar conditions to Earth is not an extraordinary claim. It's just an ordinary claim to say under similar circumstances, you will get life and eventually intelligent life. And most stars in the Milky Way galaxy, 100 billion of them, formed billions of years before the sun. So we are late for the party. They may have been before us. So it's an ordinary claim that requires ordinary evidence. When people make this statement, they also imply that we should not invest any funds in searching for them. And without seeking evidence, how can we find them? It's a self-fulfilling prophecy. So my point is that within the scientific community, innovation is suppressed by people who assume the answer in advance. when I was a kid, I was most frustrated by the adults in the room because I would ask them a question and they would pretend to know the answer. And the one reason I became a scientist is because I don't care what other people say. I don't care how many likes I get. I just want to figure out the answer based on evidence. That's the way a detective works. We shouldn't assume anything. But if we don't collect data, we will never find anything new. Now, another important point is new scientific knowledge doesn't fall into our lap. To find the Higgs boson, the CERN invested $10 billion in the Large Hadron Collider. To find the first generation of stars and galaxies in the universe, the scientific version of the story, the biblical story of Genesis, we had to invest $10 billion in the Webb telescope. I was one of the people in the first advisory committee that designed back then the next generation space telescope. My point is, in order to find something new, you need to invest resources, time, and effort. It's a lot of work. You can't just sit on your chair and figure out the answer the way most people do. And just to give you an example, we are familiar with objects that have a positive mass. We are also aware that the universe is not just expanding, but its expansion is accelerating. So we see evidence for negative gravity that is repulsive, pushing the universe apart. And if we had access to a negative mass, just like there are positive and negative electric charges, if you put a negative mass next to a positive mass, the total mass would be zero. This object would float under gravity, and you wouldn't need any fuel to move it around. So when they look at Starship, our best rocket, whoever has an access to a negative mass would laugh at it. We are putting most of the mass in the fuel of the rocket. It's a huge, gigantic thing, and if they had access to a negative mass, that would not be necessary. You would just use the payload plus the negative mass that balances it. Just to give an example of something beyond our knowledge, if negative masses exist or not, we don't know if you can bottle this dark energy that fills up the universe. Now, the Galileo Project at Harvard University was established a few years ago, and it followed the first report from the Office of the Director of National Intelligence to Congress. And I suggested also to NASA just around that time that they should look into that. This is a subject where the intelligence agency cannot really make a lot of progress on because the data is limited. So why not build observatories monitoring the sky? The sky is not classified. Astronomers have been looking at the sky for a while. The oceans are not classified. We just need sensors and then analyzing the data with the state-of-the-art AI software. That's all we need. So this was not happening. And I'm not happy with looking at past reports, because when you look at past reports, you have very limited data. And you can't make a lot of progress. If the data is fuzzy, you can't really get it to be crispier. But if you have a working observatory that monitors the sky all the time, all the oceans, and you see something unusual, you can try and collect better data. And therefore, I always say, the best is yet to come. If we were curious enough, and that's what we should be, we can collect data, forget about the hundreds of reports from the past, and have a collection of millions of objects that we look at. That's what the Galileo Project is about. And in the future, we can get very good data with equipment that was never tried before, because astronomers usually focus on a small part of the sky and look at things that are far away. They ignore objects flying overhead. And the Galileo Project has developed an observatory at Harvard University first that monitors the sky in the infrared, optical, radio, and audio. And as of now, we are actually doing triangulation. We have multiple units that look at the same object from different directions so that we can figure out the distance, the velocity, the acceleration of the object. That's extremely important. And we are building additional observatories, one in Pennsylvania, another one in Nevada. Hopefully by the end of the summer, we'll have 3 observatories collecting data on a few million objects every year. And I say, even if 1 in a million is of extraterrestrial origin, that would be the biggest discovery that humanity ever made. It would mean that we have a partner. We shouldn't assume anything about the neighbor. But it would be useful to figure out what they are capable of, because we can do better. They're probably more advanced than we are if they reached our backyard before we reached their backyard. So we collected data on many, by now, millions of objects. We analyzed it. And obviously, we are happy to share the data with whoever is interested. But also, over the past decade, the first objects from outside the solar system were discovered for the first time by astronomers. There were 3 of them. The first was identified by US government satellites that are monitoring the Earth for any ballistic missiles being launched by adversarial nations. And in 2014, they noticed an object that collided with Earth and exploded with a fireball that released 1% of the Hiroshima atomic bomb energy. And they decided it's not human-made, and therefore it can be shared with the astronomy community. So NASA published a catalog of all these meteors over the past decade, and one of them was this one. We looked at the catalog and uncovered it and realized that it came from outside the solar system because it was moving very fast. It was moving faster than 95% of the stars in the vicinity of the sun outside the solar system. And so the question is, was it a Voyager-like probe, because it's moving so fast, or maybe just a rock from another star? That was the first one. And then the second one in 2017 was a much bigger object. The first one was 0.5 meter in size. The second one was the size of the football field. It didn't collide with Earth. It would have been catastrophic if it did, because it would have killed us all. But it passed near Earth, within a sixth of the Earth-Sun separation. It was observed by a telescope in Hawaii, monitoring near-Earth objects, because we are all afraid of what happened to the dinosaurs, right? We don't want to have the same fate. And they realized this object is moving too fast to be bound by gravity to the sun. And they called it Oumuamua, which means a scout in the Hawaiian language. Now, this object at first was thought to be a comet, but there was no cometary tail around it, no gas or dust. And then it exhibited an excess push away from the sun without any rocket effect acting on it. And moreover, it had a very extreme shape, most likely flat, like a disk, based on the reflection of sunlight. The amount of sunlight reflected from it changed by a factor of 10 every 8 hours as it was tumbling. Very unusual object. So it wasn't clear. It's not an asteroid. It's not a comet. What is it? And I suggested, well, maybe it's space trash, an empty trash bag from another civilization. So that was 2017. And then, And then there was, I'm not sure. Okay, then there was a comet, which looked just like the comets that we are familiar with in 2019, also came from outside the solar system based on its speed. And my colleagues said, well, this one looks familiar, so doesn't it convince you that the others are also natural? And I said, well, if you go down the street and you see a weird person, and after that you see a normal person, it doesn't make the weird person normal. So Oumuamua was really strange, most likely flat, and it's not clear what it was. I suggested maybe it's a very thin object pushed by sunlight, reflecting sunlight. And in fact, a lot of technological debris that we produced is being pushed by reflecting sunlight. In fact, I'm not sure, but okay. In fact, the space trash that we produce, on January 2nd, 2025, just this year, an amateur astronomer noticed an object passing near Earth, and it was cataloged as a near-Earth asteroid. 17 hours later, it was realized, oh, this object moves exactly the same way as the Tesla Roadster car that was launched by SpaceX in 2018, Elon Musk. It is a car. It's not an asteroid. They removed it from the catalog. And I actually have a bet with Elon. I am willing to put 1% of my net worth against 1% of his net worth to search, to check if there is any other space entrepreneur who is more accomplished than he is since the Big Bang, 13.8 billion years ago. Let's figure it out. It's not a lot of money for him. And then, actually in 2020, there was the same telescope in Hawaii that discovered the Oumuamua, discovered another object that was pushed by reflecting sunlight. And then after a few weeks, the astronomers realized, oh, that's a rocket booster from a 1966 launch by NASA. So we know that some of the objects that are unusual, being pushed by sunlight, are human-made. The question is, who produced Oumuamua? And my point is that the next Copernican revolution, remember, Copernicus realized we are not the physical center of the universe. I actually visited Poland a year ago, a day after visiting the Munich Security Conference, where I spoke as the first astrophysicist that ever, by the way, I saw on the roof of the hotel at the Munich Security Conference, there were snipers with black head covers. They were there to protect the politicians. I realized being an astrophysicist is really very fortunate, but nobody wants to kill me. But at any rate,
It's overrated, Avi.
the next Copernican revolution is that we are not at the technological center of the universe. We have something to learn from a smarter kid on our cosmic block. And I wrote a paper a couple of months ago where I explained that with a space telescope, we can actually go through the million objects, roughly meter in size, within the orbit of the Earth around the Sun that came from outside the solar system, and figure out whether among them, among all the rocks, there is space trash from other civilizations, because over the past billions of years, they predated us and they polluted interstellar space because we sent out 5 probes, Voyager 1, Voyager 2, Pioneer 10, Pioneer 11, and New Horizons. They are heading out of the solar system towards interstellar space. We did it over 50 years. Just think how many more we would produce in the next billion years. And all of that keeps accumulating like plastics in the ocean. All of this trash produced by other civilizations. And we just have to look in our backyard and figure it out. Again, $1 billion will go a long way in this direction. But right now, this subject is outside the mainstream of astronomy. Instead, the highest priority defined by the Decadal Survey is to spend more than $10 billion in the search for microbes, for the molecular fingerprints of microbes in the atmospheres of exoplanets. And frankly, I am much more excited about finding intelligence than finding microbes, for a simple reason, that we can learn from a higher level of intelligence. One reason I seek intelligence in interstellar space is because I don't often find it here on Earth. And you may ask, where will Voyager be in 1 billion years? It will be on the opposite side of the Milky Way galaxy. So if most stars formed billions of years before the sun, we know that for a fact, they had, if there were civilizations like us out there, they had plenty of time for their spacecraft to reach us. And we haven't really checked. Until the last decade, we didn't really know about interstellar objects. So I'm saying this is new. Now, the Meteor, the object that collided with Earth, was interesting because for a cost of $1.5 million that I received from a donor, we were able to go to the Pacific Ocean and search for materials left over from this interstellar object. It exploded only 20 kilometers above the surface of the ocean, and that implied that it had material strength tougher than all other hundreds of meteors in the NASA catalog. So it was unusual in its material strength, in its speed, and the question was, could it be a Voyager-like meteor? Could it be a Tesla Roadster car-like meteor? Because that car actually will collide with Earth probably in several tens of millions of years. And my colleagues, if there are any astronomers at that time, they might argue it's a rock of attack that we've never seen before. So actually, the US Space Command looked back at the data after I reached them through the White House, and they confirmed, yes, this meteor actually came from outside the solar system. The data was reliable. And they also released the light curve of the explosion that indicated how much energy was released and at what altitude was the explosion. And so I decided to lead an expedition to the Pacific Ocean. We went there slightly less than 2 years ago. And what you see here is the deck of the ship that was fittingly called Silver Star. We built a sled with magnets on both sides, and we placed it on the ocean floor, which was 1 mile deep. And we surveyed a region that is 7 miles in size, looking for any molten droplets left over from the explosion, just to figure out, was it a natural rock or maybe a gadget? And I told my students before I left, if we find a gadget and it has buttons on it, should I press a button? The opinions were split. Half the class said, please don't do that. He put all of us in at risk. And the other half said, please do. We would like to see if it's ChatGPT 100. So we brought back materials. And it was a 2-week expedition. I put all the materials in this black suitcase and shipped it by FedEx to my home, and then brought it to the laboratory of my colleague at Howard Stein Jacobson, who is a world-renowned geochemist that has the best instruments in the world. And on the other side of me in this photo is the summer intern, Sophie Bergstrom, who worked with me that summer, and she discovered 850 molten droplets within the materials that we brought back. And I gave her the honorary title, the Spherules Hunter. And you can see here what these molten droplets looked like. They were very distinct relative to the background sand, and we picked them out with tweezers and published the results. And so there was one type of those molten droplets, about 10% of the entire reservoir, that looked very unusual. They had a composition, a chemical composition that was very different than solar system materials, up to 1,000 times higher abundance of beryllium, lanthanum, uranium than you find in solar system materials. And so that's a possible indication that we found some material from the original object, but we want to go back and search for bigger pieces with a robot that we will put on the ocean floor. It will cost $6.5 million. We don't have a funder as of yet. If anyone is interested in joining us, let me know. This is an image from the last day of the previous expedition where I was standing on the ship looking at the sunset. And next to me is an 88 years old Art Wright, who was a commander of a destroyer during the Vietnam War. And I really liked him because he wouldn't speak much. He would solve problems. And everything he said was true. And there aren't many people like that these days. What you find most often are people that are virtue signaling, that are trying to impress you. That's partly the culture of social media. But this mission was a success thanks to art. And he reminded me of my father. I really liked him. Now, this year, in August 2025, there is a new observatory in Chile that was funded by the Department of Energy and the National Science Foundation. It's called the Vera C. Rubin Observatory, and it will survey the southern sky every 4 nights and could find Oumuamua-like objects every few months, if they are out there. And now we know to look at them in much greater detail. We can use the Webb telescope to do that. And this telescope will use a camera that is 3.2 gigapixels in resolution, so 1,000 times more than the number of resolution elements you have in your cell phone. So I'm very excited about the coming year or two. We will have new results from the observatories that the Galileo Project is building. We will have potentially a new expedition where we can look for bigger pieces of this first interstellar meteor, and the Rubin Observatory might find more Oumuamua-like objects. But if we really want to make fast progress, we need more funds. If I had $100 million or $1 billion, I know exactly what needs to be done, and we can get much better understanding of our cosmic neighborhood. As I said before, the software that we develop would be of great use to the Department of Defense. Thank you.